Okay, welcome to the 6.2 lesson. Hopefully this video will help you understand what's going on. If you can't watch it in class, go ahead and watch it at home. I'm going to make a note of everything that we are going to learn today. I think you guys are going to do just fine about it. We are going to skip the starter today because I'm not here. So go ahead and go to page 11, your 6.2 notes. And remember I told you last time that we're going to have quadratic key feature vocabulary at the beginning of every unit or beginning of every lesson. This one, we only have 3 to do today. So the axis of symmetry, the definition of that is the imaginary line that divides a parabola in half. And I know that might be really confusing, but it's going to become pretty clear. All of our parabola points, so every single one of our parabola points reflect across this line. And that is why when in the last lesson we had a 1 and a 1 and a 2, an 8 and an 8, and I will show you what that means. We always do our axis of symmetry as x equals a number. Always, always, always. So, for example, if I draw my little parabola on this graph, the axis of symmetry is an invisible line that goes right down the middle of our things. My imaginary invisible line, I drew at x equals 4, and we would write that key feature as x equals 4. Okay, increasing and decreasing go along with the axis of symmetry. We're going to use the axis of symmetry to help us understand. So increasing is all when the values of x for which the graph rises or goes up. Like if I put a car on it, it would go up from left to right. All right, so if I have a parabola, I draw it in purple. So remember, these are the values of x. So if I have a concave up parabola that points up, okay, where my graph rises would be this. That's where my graph is rising from that axis of symmetry. So when I have a concave up parabola, right, it's to the right of the axis of symmetry, and I just abbreviate that as big A, little o, s. It's the x values, so this x value right here is -5, and then I'm going from left to right. That's my left number, and my right number is infinity. It will get bigger and bigger and bigger on the right. If I have a concave down parabola, yeah, let's do it there. Okay, concave down parabola. This time, my increasing, because I go from left to right, so this is increasing until here. So it'll be to the left of the axis of symmetry. My left numbers are really big in negative numbers. I use the symbol of negative infinity, and my graph stops increasing at 2. I do not use brackets like I did on range, and the reason for that is at the vertex, if you remember from last time, we call it the turning point. And that is where our graph stops increasing or decreasing and changes to the other thing. And because that vertex point is neither increasing nor decreasing, that is why we use the parentheses. So remember, we're only using the brackets on the range. Okay, so then we are going to do decreasing, and I know this will be very shocking to you, but this is the values of x for which the graph decreases or falls from left to right. We always go from left to right because that's how we read, and so that's how we read a graph. So if we come over here, we're going to do the same thing again. So we have our parabola, our concave up parabola. All right, so where my graph falls. So this is where my graph is falling, and it falls to that axis of symmetry. So if I have a concave up parabola, I am falling to the left of the axis of symmetry. So I'm going to start falling at all the really big negative numbers, and I'm going to stop falling at my axis of symmetry, which is at -5. Now, for my concave down parabola, I'll put it in the same place over here so you can kind of see what's happening. So on my concave down parabola, I'm falling starting at the axis of symmetry. So that is to the right of the axis of symmetry. So I start falling at -5, I stop falling at really big positive numbers. So now what we're going to do is the same graphs that we had last time, we're going to use them to identify key features. So here is where my axis of symmetry is. That happens at x equals 2. That is the equation of that invisible line. So increasing, I'm increasing, it's a concave up, so I'm increasing to the right of my axis of symmetry. So I start increasing at the 2, and I increase to the really big positive numbers. For decreasing, I start decreasing at, and then I stop at the axis of symmetry. So I start at the really big negative numbers, and I stop at the axis of symmetry. In example B, my axis of symmetry is right at the vertex. So my axis of symmetry happens at x is equal to -4. This time I am increasing on the left side of the axis of symmetry. So really big negative numbers, I stop increasing at -4. That's where I turn. And my decreasing is on the right side of the axis of symmetry. I start going down at -4, and I go down to infinity. That's where this section of the video is going to end. Get video 2 to get the graph, how to graph on the rest of the lesson. We're going to graph in vertex form.